You open your eyes to a sky that feels heavier than usual, not because of clouds, but because of everything else drifting within it. The stars shimmer in familiar constellations, yet between them, new points of light seem to have appeared, faint, uncertain, like whispers too shy to speak aloud. Somewhere among those silent wanderers, 3I Atlas is moving closer to Mars. It was supposed to be just another interstellar traveler, a frozen fragment from a time before our sun was born, passing quietly through our solar system before fading back into the dark. But this time, something feels different. As 3I Atlas approaches Mars, something around it has begun to multiply. At first, astronomers noticed a few extra dots in the telescope images, tiny reflections moving just behind the comet's shimmering tail. They thought it was noise, perhaps an imaging artifact, or fragments kicked free by a burst of gas. But night after night, the number of those faint companions kept growing. 2 became 4, 4 became 8. The frame-by-frame playback of the sky seemed to show replication, not debris. You imagine standing under that sky, feeling the distance stretch between your heartbeat and those glowing points. What could possibly cause something like this? The rational mind reaches first for science, sublimation, outgassing, micro-ice fractures. Yet deeper inside, another part of you, the one that dreams, wonders if the universe sometimes arranges its accidents too beautifully to be accidents at all. Astronomers remind us that 3I Atlas poses no danger to Earth. Its hyperbolic orbit will carry it past Mars at a safe distance before it drifts outward again, back toward the void between the stars. Still, the data invites a question too large to ignore. Why does the number of these companions keep increasing? And why now, while 3I Atlas glides through a part of space that should be silent and empty? Every time we think we've mapped the chaos, the cosmos reminds us of how little control we have over its rhythm. We call these visitors comets, asteroids, interstellar objects, but that's just the language we use to hide how they make us feel, how they remind us of the fragile order we build around our own small lives. As images of the object stream in, you can almost sense a quiet hum behind the data, a faint pulse running through each frame. Scientists debate whether these multiplying lights are the result of physical stress fracturing the nucleus, or a swarm of dust grains reflecting sunlight in perfect synchrony. But neither explanation feels entirely satisfying. There's a precision to it, a kind of choreography in the way they move, expanding outward in measured rhythm. Perhaps it isn't about what's multiplying, but why our attention is drawn to it. The more closely we look, the more the pattern seems to answer our gaze. Maybe the cosmos is simply showing us how perception works, that every mystery expands the moment we decide to notice it. Somewhere deep in the quiet between Mars and the Sun, 3I Atlas continues its path. A pale, turquoise filament of dust trails behind it, glowing softly against the cold backdrop. Each of its fragments, whether real or imagined, mirrors our own search for meaning, our own instinct to see purpose in patterns of light. If you close your eyes for a moment, you can almost feel it passing overhead. A visitor from another system, carrying questions older than our species, breaking into smaller pieces as if to share its story with more corners of the sky. So tonight, we begin again, with curiosity as our compass. We'll follow 3I Atlas as it nears Mars. We'll trace the pattern of these multiplying companions and ask what they reveal about the universe, and perhaps about us. Because sometimes the universe doesn't speak in words or symbols. It speaks in repetitions. It shows us one light, then another, until we finally stop to listen. What if those faint companions aren't debris at all? but a pattern we barely recognize. The night sky of September has rarely looked this alive. Through telescopes across Earth, the heavens seem to hum with movement. A dozen small bodies drift near the planet's orbit, each one reflecting sunlight in quick, sharp flashes before sliding quietly into the dark again. To the naked eye, it would appear calm. But to the sensors and mirrors watching from mountaintops and orbiting satellites, space feels almost crowded. FA-22 was the first to announce its arrival, a rock roughly the size of a football field, gliding by at a distance of just over 2 lunar orbits. Then came RJ-2, even closer, slipping within a fraction of that range, only 0.78 lunar distances away. Astronomers call it a near miss, but the word near in cosmic terms can mean both safe and uncomfortably intimate. These visitors pass unseen, yet their gravitational whispers ripple through our datasets, reminding us that our planet moves through a living sea of debris, not an empty void. And it didn't stop there. Another set of sub-lunar objects appeared, each smaller, each quicker, streaking past like quiet punctuation marks at the edge of our awareness. The pattern was undeniable. Earth, for this brief window of time, seemed to be standing in the middle of a celestial migration. While these asteroids brushed past, another performer took the stage in a different part of the sky. The comet C2025R2, better known as Swan, began to brighten near the constellation Virgo. Amateur astronomers first noticed the glow deepening night after night, a soft blue-green bloom that hinted at volatile gases awakening in the warmth of the inner solar system. To some, it felt like the universe had scheduled a cosmic parade, rocks sweeping by close to Earth while a comet flared to life in the background. But beneath the beauty, the scientific instruments saw something else, a data overload. Observatories around the world were running at full capacity, scanning, classifying, comparing trajectories. Among them, one stood out, the Vera C. Rubin Observatory in Chile, whose massive 8.4-meter mirror had just begun its wide-field sky survey. Designed to map the entire visible sky every few nights, it suddenly became humanity's pulse monitor for the cosmos. Every new scan seemed to reveal more movement, more objects, more stories hidden in the darkness. With this new vision came a new paradox. The more clearly we looked, the busier the universe became. Dots of light that had always been there were now tracked, catalogued, and named. Some of the new objects weren't new at all. They had simply been invisible until our technology learned how to listen more carefully. And yet, among the expected discoveries, there was something unsettling. A handful of faint linear clusters seemed to move in step with one another, all following a rough trajectory similar to that of 3I Atlas. The observations came from separate teams, separated by continents and weeks, yet their data aligned. These weren't random points scattered across the background. They formed quiet echoes of motion, like chords resonating to the same rhythm. For a moment, it almost felt choreographed. The question whispered across observatory control rooms and data forums alike. Why now? Why did this sudden increase in visitors, both interstellar and local, seem to coincide with 3I Atlas's journey through our neighborhood? There was no evidence of a direct link, of course. The cosmos is full of coincidences, and human minds are excellent at mistaking coincidence for connection. Still, it was difficult not to notice the timing. Just as 3I Atlas approached the orbit of Mars, the solar system itself appeared unusually active, as if holding its breath for something unseen. Maybe it wasn't that the sky had changed, but that our attention had. Observation is its own kind of creation. When we choose to look deeply enough, the universe responds with infinite complexity. What feels like a sudden crowding of celestial traffic might simply be our new ability to see what was always there. Standing outside under that September sky, you might imagine each object, FA22, RJ2, Swan, and the countless unnamed ones, as beads on invisible threads weaving through space. Each is a story of motion, of frozen matter awakened by sunlight, of gravity gently reshaping the architecture of orbit. None of them are here by accident, and yet none are here for us. Their meaning exists only because we choose to notice. Still, even among scientists who live by data, there's a sense of wonder that refuses to fade. It's the awareness that every observation, every flicker of light, carries both truth and illusion. Instruments show us reality, but perception turns that reality into narrative. When hundreds of new objects appear within a single month, it feels like a message, whether or not one was ever intended. So as September draws its slow curtain across the night, the scene is set. Earth sits beneath a sky alive with motion, asteroids brushing past, comets awakening, interstellar travelers slipping through the gaps. Somewhere beyond Mars, 3I Atlas continues its strange journey, trailed by companions whose numbers seem to grow with each passing day. And through it all, the question lingers, not as a warning, but as an invitation. Perhaps nothing extraordinary has happened at all. Perhaps it's only that we've finally built eyes sharp enough to see the universe's quiet rhythms. The sky didn't suddenly get busier. We simply gained the eyes to notice. Imagine, for a moment, that one of those small, silent visitors did not pass us by. Let's say FA22, that 100-meter-wide fragment of rock and metal, missed its perfect trajectory by just a little. Not enough to doom the planet, just enough to remind us of the energy sleeping inside every orbiting stone. In space, FA22 looks harmless, a dark pebble adrift in sunlight, moving quietly through the vastness. But velocity changes everything. Traveling at over 40,000 miles per hour, that pebble becomes a weapon of unimaginable force. If it were to strike Earth's atmosphere, the energy released could rival the largest nuclear detonations ever conceived, between 50 and 100 megatons of TNT. That number is almost impossible to imagine. So picture it this way. One flash brighter than the sun. One wave of pressure sweeping outward faster than sound. One moment when the sky itself becomes a wall of heat. Most asteroids of FA22 size never reach the ground intact. Friction tears them apart high in the atmosphere, transforming them into an airburst, a sudden explosion of energy that releases its fury miles above the surface. The blast compresses the air beneath it, producing a shockwave that spreads like ripples across a pond. Except the pond is a city, and the ripples are walls of wind moving at hundreds of miles per hour. Over an urban area, an airburst like that could shatter glass across 100 miles, flatten buildings for dozens more, and ignite everything flammable within line of sight. On open plains, it would carve a temporary desert out of whatever had stood there moments before. Over the ocean, the physics change, but the violence does not. The energy would throw columns of water skyward, generating tsunamis that would roll outward in expanding circles. By the time they reached land, much of the height would fade, but the volume, the sheer mass of displaced sea, would still be enough to devastate coastal areas. The waves would not look cinematic, just relentless. They would rise, pause, and move inland with the weight of entire neighborhoods carried within them. These are not apocalyptic scenarios. They're part of the natural vocabulary of planetary defense, our way of measuring the risk that lives in the skies above us. The Earth has worn the scars of such encounters many times before. The Tunguska event in 1908 leveled thousands of square kilometers of Siberian forest. In 2013, a smaller rock, only about 20 meters wide, exploded above Chelyabinsk, Russia, shattering windows and injuring more than 1,000 people. That one came from the direction of the sun, invisible until it was too late to do anything but watch the sky bloom with fire. That's what scientists call the solar blind spot. Our telescopes, for all their reach, can't easily see objects approaching from the sun's glare. It's a simple truth that still humbles us. The greatest risk may not be what's out there, but what's hidden by the light we depend on. Now imagine that some of those small, multiplying companions around 3I Atlas shared a similar trajectory, not toward Earth, but near enough that their paths intersect the inner system, close enough to warrant a second look. We don't assume danger, we assume curiosity. Each small fragment becomes a test case for how well our instruments can track, predict, and react. The purpose of exploring risk isn't fear, it's literacy. The cosmos is full of movement, and our safety depends on understanding that motion in detail. When scientists simulate impact scenarios, they aren't forecasting doom, they're rehearsing composure. Every model, every calculation, every radar ping trains us to respond not with panic, but with precision. So the next time an alert flashes across the astronomical networks, it won't begin with dread, it will begin with data. Observers will measure brightness, trajectory, angle of approach. Analysts will calculate airburst altitude and potential energy. Agencies will coordinate simulations and mitigation plans. The process will unfold with calm urgency because this is what preparation looks like, a choreography between curiosity and caution. To the untrained eye, this may sound grim, but in truth, it's reassuring. We've moved from guessing to measuring, from fear to fluency. The sky still holds surprises, yes, but it also holds systems, layers of observation and collaboration designed to make those surprises less catastrophic. When you picture FA-22 now, don't imagine a disaster movie. Imagine a laboratory, one that stretches from the mountains of Chile to satellites orbiting hundreds of miles above you. Every scan, every detection, every new asteroid added to our catalogue is a sign of progress. The more we see, the more we know. And the more we know, the less we fear. Prepared minds don't panic, they measure. Not every visitor from the sky arrives with mystery. Some come with rhythm, predictable, periodic, almost musical in their timing. They remind us that space isn't empty chaos but a dance of returning guests, each tracing an orbit set in motion long before humanity learned to name them. Take Comet Swan. It wasn't first seen by human eyes, but by an instrument designed to measure ultraviolet light, the solar wind anisotropies camera aboard the SOHO spacecraft. In the faint blue glow of hydrogen emissions, Swan announced itself not with a roar, but with a shimmer. A diffuse puff of water molecules torn apart by sunlight became the comet's calling card. As it drifted closer to the sun, its core began to boil, jets of vapor bursting from fractures in the ice. The brightness grew nightly, a greenish veil expanding across the stars of Virgo. But beauty in the solar system often comes at a price. The closer a comet gets to the sun, the greater the tension between cohesion and disintegration. Many of them never survive their perihelion, their closest approach, without fragmenting into ghostly dust streams. Swan 2 carries that risk. It's a reminder that even the most graceful arcs across the heavens are temporary, and that destruction in this cosmic cycle is just another way of reshaping matter for future journeys. While Swan glows faintly at the edge of dawn, another traveler waits for its own rendezvous with Earth, Apophis, the asteroid once feared to pose a real threat to our planet. The year 2029 will mark its close approach, a pass so near it will fly within the orbits of our geostationary satellites, just 32,000 kilometers above the surface. For decades, it haunted simulations and headlines alike. But newer calculations have cleared its name. Apophis will miss us entirely, so precisely, in fact, that its orbit will become a natural experiment. When it skims by, Earth's gravity will stretch its body, slightly altering its spin and reshaping its surface. And NASA's OSIRIS-APEX mission will be waiting. After completing its sample return triumph at Bennu, the spacecraft has been reassigned to shadow Apophis during its flyby, to watch how tidal forces rewrite a small world in real time. What once sounded like a disaster scenario is now a rare classroom in motion, a demonstration of how planetary defense and curiosity intertwine. These comets and asteroids, Swan, Apophis, and countless others, follow a kind of pattern, a choreography woven into the architecture of our solar system. Every year brings waves of these visitors, their trajectories determined by gravitational resonances, their returns mapped like verses in a cosmic song. Their behavior may seem random, but it obeys rules older than our species. And within that rhythm lies the secret of perspective. When we recognize how common these movements are, we learn to distinguish what's truly unusual. Most celestial guests belong here. They're part of the ongoing circulation of the system. But sometimes one arrives from elsewhere, from beyond the heliosphere, from another star entirely. That's when familiarity ends and mystery begins. 3I Atlas is one of those exceptions. Not bound by the sun, not shaped by our planetary family, it crosses the solar system once and never returns. Its orbit isn't an ellipse. It's a hyperbola, a mathematical expression of farewell. To watch it glide among the usual comets and asteroids is to see something alien borrowing the language of the familiar. Imagine a planetarium filled with overlapping paths, Swan tracing its fragile loop toward the sun, Apophis preparing its near-Earth flyby, and threading through them both, 3I's Atlas, an interstellar messenger slicing diagonally across their neat geometry. It's like hearing a single note played by an instrument from another world, joining a song it was never meant to know. This is what makes the present season so remarkable. The solar system, normally a quiet clockwork of repetition, is momentarily crowded with coincidence. A brightening comet, a returning asteroid, and a traveler from the stars all share our sky. To scientists, it's a logistical challenge, so much motion to track at once. To dreamers, it feels like meaning. The beauty of this pattern is not that it's rare, but that it reveals contrast. When we look closely at the ordinary, the periodic comets, the routine flybys, we train our perception to notice the truly strange. 3 Atlas doesn't stand alone against an empty backdrop. It stands out precisely because the rest of the system is so consistent. In the coming moments, we'll shift our focus from the familiar choreography of solar visitors to the singular path of this interstellar one. We'll watch it near Mars, and we'll see how the mystery deepens when the patterns we know meet something that follows none of them. To see what's unusual, we first learn what's ordinary. When astronomers first plotted its path, they almost didn't believe it. The orbit wasn't a neat ellipse, looping obediently around the sun like the rest of our cosmic family. It was open, an arc that would never return. A hyperbola, steep and uncompromising, carved across the solar system from the deep dark between stars. That shape alone gave it away. This was not one of ours. 3I Atlas, the third confirmed interstellar visitor in human history, was detected in early July 2025. Its designation, C2025N1 Atlas, came from the system that first saw it, the Asteroid Terrestrial Impact Last Alert System in Hawaii. At first, it seemed unremarkable, a faint magnitude, 18 blur in a crowded sky. But when its motion was tracked against background stars, the math broke expectation. The eccentricity of its orbit exceeded 1. In cosmic shorthand, that means it comes from elsewhere. Projected forward, its path showed a near miss with Mars, an elegant, harmless flyby, close enough for clarity, far enough for comfort. The geometry promised perfect conditions for observation: low solar glare, wide elongation angles, and the synchronized alignment of telescopes on Earth and in orbit. As August faded into September, the anticipation grew. Through the eyes of the James Webb Space Telescope and ground-based observatories from Chile to the Canary Islands, Atlas revealed a strange kind of beauty. Its coma, the cloud of vapor and dust surrounding its nucleus, wasn't the typical mix expected from icy wanderers. The ratio of carbon dioxide to water was abnormally high, far beyond what standard comet models predict. Where most comets exhale water as they near the Sun, Atlas seemed to breathe carbon. Spectral readings told the rest of the story. The signal for nickel was strong, almost unnaturally so, while iron, its usual companion, was subdued. Nickel and iron are siblings in cosmic chemistry, forged together in stellar furnaces. To see one dominate while the other hides was like hearing a song missing half its harmony. Scientists debated whether cosmic rays or interstellar weathering might have restructured its surface, stripping away iron while leaving nickel-rich veins to sublimate under sunlight. And then there was the tail, or rather tails. Multiple structures streamed behind Atlas, some broad and diffuse, others sharp and narrow, each glowing at slightly different wavelengths. One was made mostly of gas, another of fine dust, and a third seemed to pulse in brightness over several days. The pattern suggested bursts of outgassing, like a heartbeat recorded in light. Every few days, the comet would flare, its luminosity doubling or tripling before settling again. These flares complicated the question of its rotation. If the nucleus was spinning fast, we'd see regular cycles of brightness as jets turned toward and away from the Sun. But the timing of Atlas's bursts was irregular. Some models suggested a very slow rotation, perhaps a single spin every few days. Others hinted at something even stranger, a tumbling motion where the object rolls unpredictably, like a stone skipping through dimensions of inertia. As it neared Mars, Atlas passed into the view of the red planet's orbiters. The Mars Reconnaissance Orbiter, along with ESA's Trace Gas Orbiter, captured faint reflections trailing the comet. At first, they were thought to be background stars, misregistered by tracking software. But when aligned chronologically, the images showed movement, small, dim points shifting in tandem with Atlas's path. The number of these faint trails grew with every observation cycle. What began as 3 or 4 became nearly a dozen within a week. The press releases were cautious. Possible fragmentations or associated dust clumps detected. Yet inside research teams, curiosity ran wild. Were these secondary fragments, pieces of Atlas breaking apart under solar stress, or were they transient formations of dust and ice, gravitationally herded but not bound? Data analysts began to compile a timeline. Each night's exposure stacked atop the last, building a plot of brightness and count. The graph sloped upward. The companions were multiplying, not exponentially, but steadily, like a rhythm unfolding in slow motion. 3 hypotheses emerged. The first, fragmentation, the simplest and most natural explanation. As 3i Atlas nears the Sun, pockets of trapped gas expand and rupture the surface, releasing shards that drift in the same general trajectory. These fragments, still reflecting sunlight, appear as discrete points in the data. The second, temporary aggregation. In the vacuum of space, particles don't always separate. They sometimes cling. Electrostatic charges, microgravity, and temperature gradients can coax dust and ice grains into brief unions, forming small clusters that scatter light efficiently. The multiplying objects could be swarms of reflective clumps, not solid bodies. And the third, optical echo, a trick of observation. As telescopes track moving targets, the alignment of sensors, atmospheric interference, and software corrections can produce faint ghost trails that mimic real companions. In other words, the pattern might belong more to our instruments than to the comet itself. The teams began eliminating possibilities. Tracking data from independent observatories showed the same points of light, ruling out purely optical artifacts. Their motion vectors, however, didn't align perfectly with Atlas's spin axis. That ruled out mechanical ejection or artificial control. What remained was elegant in its simplicity: natural fragmentation, a process both chaotic and serene, unfolding just as physics would predict, though never so poetically. Even through data and diagrams, the image is mesmerizing. Picture Mars glowing in the background, its red disk cut by shadows of its own moons. Across that backdrop, a thin turquoise plume sweeps past, 3E Atlas, shimmering like a brushstroke across space, and trailing behind it, a delicate chain of lights, each one a smaller echo of the whole, drifting further apart with time, a cosmic rosary, scattering bead by bead into infinity. Scientists measure it, catalog it, graph it. But for those watching live, through lenses or from quiet mountaintops, it's impossible not to feel something deeper. The idea that matter, under pressure and light, can create its own reflections. That one traveler from the void can multiply not just physically, but metaphorically, into questions, into wonder. Closer to Mars, the question multiplies with the companions. When the sky fills with new points of light, the first instinct is unease. More dots mean more possibilities. And in a universe where speed and mass equal energy, every possibility carries weight. Yet what separates worry from wisdom is process. How we detect, predict, and prepare. The story of planetary defense is not one of panic, but of discipline. In 2022, the DART mission turned theory into fact. A small spacecraft, no larger than a delivery truck, slammed into the asteroid Dimorphos, altering its orbit by more than 30 minutes. It was humanity's first deliberate nudge of a celestial body, proof that we could, in principle, defend ourselves through kinetic impact. A single strike changed the dance of two ancient rocks, not by destroying, but by redirecting. The crater became a symbol not of violence, but of precision. That success paved the way for the European Space Agency's follow-up mission, Hera. Scheduled for 2026, Hera will visit the same asteroid pair to measure exactly how the impact worked, how the momentum transfer behaved, how ejecta spread, and how the shape of Dimorphos evolved. Together, DART and Hera form the two halves of a single experiment, cause and comprehension. One taught us that deflection is possible. The other will teach us how to perfect it. But impact prevention begins long before the impact. It begins with seeing. For years, our greatest vulnerability has been the sun itself. Objects approaching from its direction vanish into glare, hidden until they burst from brightness, too late to warn anyone. This solar blind spot has always been the weak link in planetary awareness. That's where the next generation of observatories steps in. The Vera C. Rubin Observatory, already mapping the sky with unmatched cadence, acts as our global wide-angle lens. Its 3.2 gigapixel camera captures the entire southern sky every few nights, automatically comparing frames for movement. Meanwhile, NASA's upcoming NEO Surveyor spacecraft, scheduled for launch later this decade, will observe in infrared from a vantage point far from Earth able to detect warm objects even against the solar backdrop. Together, they shrink the universe of uncertainty, turning surprise into statistics. When new data arrives, a cascade begins. Detection triggers cataloging. Cataloging triggers prediction. The system evaluates each object by 3 key parameters: size, brightness, and trajectory. Brightness suggests reflectivity. Reflectivity suggests size. Orbit models refine with every observation, feeding into simulation software that maps possible futures. Each step narrows the cone of probability until the object's threat level becomes clear. Now, with 3i Atlas in focus and its growing number of companions, that same pipeline activates almost automatically. Every faint signature trailing the interstellar object is treated as a potential near-Earth candidate until proven otherwise. Analysts input their data: albedo high, dimension small, projected velocity relative to Mars, not Earth, confirming negligible impact risk. These are objects of fascination, not fear. Still, the procedure continues. Each new speck receives a provisional designation, its coordinates logged into the Minor Planet Center database. Tracking software predicts motion for the next 30 days, flagging any object that drifts outside expected error margins. Ground telescopes then recheck positions, refining the orbit again. It's an endless cycle. Observe, confirm, simulate, repeat. The system runs not on adrenaline, but on patience. This routine may sound dry, but it's the quiet miracle of coordination. Hundreds of scientists across continents, all observing the same patch of sky, all using shared protocols. A planetary-scale nervous system built from data lines and algorithms. It listens so that we can sleep. Imagine for a moment the multiplying objects around Atlas entering this network. Each detection appears as a blip on a real-time monitoring screen, some faint, some persistent. A color-coded interface displays priority: green for harmless, yellow for uncertain, red for concern. The Atlas fragments remain green. Their apparent brightness fluctuates, but their trajectories hold steady. The display updates hourly, smooth and calm. There's a subtle irony here. More dots on the screen doesn't always mean more danger. In fact, it often means more awareness. Each new object represents one less unknown. The act of naming, of plotting, of assigning identifiers transforms potential threats into pieces of knowledge. The sky doesn't become safer because there are fewer rocks. It becomes safer because we understand them. For planetary defense specialists, the multiplying companions of Atlas serve as a kind of rehearsal. They test the sensitivity of our systems, push algorithms to distinguish between fragments, reflections, and genuine bodies. They remind us that risk is not a static quantity. It changes as our instruments evolve. And so, as reports circulate about the growing number of points trailing the interstellar visitor, the tone within observatories remains calm. Charts update, models converge, probabilities shrink. The words "no hazard to Earth" appear in summary after summary. The takeaway isn't complacency, it's competence. Our species has reached a point where cosmic events no longer arrive unannounced. We don't have to guess what might happen. We measure it as it unfolds. When the first warning network was proposed decades ago, critics said the task was impossible. The sky was too vast, the objects too small. But the past few years have rewritten that assumption. From DART's collision to Rubin's all-sky maps, to NEO surveyors' infrared eyes waiting to open, the message is consistent. We are learning to see fast enough to act. And for now, as Atlas passes by Mars with its quiet entourage of fragments, we watch without fear. The numbers may multiply, but meaning stays measured. The system holds steady. More dots on the screen doesn't always mean more danger. There's a quiet seduction in patterns. the mind loves them. It seeks rhythm in noise, geometry in chaos, meaning in coincidence. It's a reflex older than language, rooted in survival. Spotting a hidden shape in tall grass once kept our ancestors alive. Today, it helps us navigate data, and sometimes it leads us astray. Psychologists call it pareidolia, the tendency to see familiar forms where none exist. Faces in clouds, figures on Mars, constellations connecting stars that share nothing but perspective. It's not madness, it's meaning-making. When confronted with uncertainty, the brain draws lines until the world feels coherent again. And once we've drawn those lines, another reflex takes over: confirmation bias. We notice what agrees with our expectations and quietly overlook what doesn't. In science, that instinct can be both gift and trap. It drives discovery, but it also builds illusions. When technology improves, our bias doesn't vanish. It just moves into higher resolution. The better our eyes, the more patterns we think we see. That's exactly what's happening now. The Rubin Observatory's deep scan surveys and the Mars orbiter's high contrast imagery have opened a floodgate of detail. We can see fainter, smaller, faster-moving objects than ever before. But the more the instruments reveal, the more our minds yearn to connect the dots. When analysts overlay all detections of 3I Atlas and its companions across several weeks, clusters emerge, dense pockets of points that seem to move together, like fragments of a hidden choreography. At first glance, it looks meaningful. The plots show streaks of correlation, lines that beg for interpretation. Some scientists whisper of structure, others shrug and call it noise. So which is it? To find out, statisticians run tests that strip emotion away. They compare the observed clustering of Atlas's companions against randomized distributions, essentially asking, would this pattern still appear if we shuffled everything? The results are humbling. Most of the apparent alignment disappears once randomness is accounted for. The clusters fall within normal expectations for fragment dispersion under solar radiation pressure. In simpler words, it looks designed, but it's physics. And this is where perception and reality part ways. Our brains are engines built to find continuity. They complete shapes that nature leaves unfinished. But the universe isn't required to draw clean lines for us. In the case of 3E Atlas, what we see as synchronized fragments are simply pieces responding to identical forces: light pressure, solar wind, and rotational stress. There's beauty in that symmetry, but it's mechanical, not intentional. Still, the coincidence is captivating. A series of dots moving together across the Martian backdrop feels almost alive. The human mind can't resist asking, if not design, then what? The answer, it turns out, lies in patience. Natural systems often imitate order before collapsing into entropy again. The birth of a snowflake, the division of a cell, the spiraling of galaxies. All look deliberate, but arise from simple feedback loops. Chaos and order are not opposites. They're partners in a conversation that never ends. In the lab, researchers simulate Atlas's breakup using dynamic models. They feed in its estimated rotation rate, density, and trajectory, then watch as virtual fragments drift apart. Within minutes of computation, the same patterns emerge: clusters, chains, even arcs. The resemblance to observation is uncanny, yet every motion is explained by sunlight, spin, and time. No hidden intelligence required. When the real data is layered on top of the simulation, the match is almost perfect. The fragments follow predictable gradients, spreading in proportion to their mass and surface area. The multiplying objects are not multiplying by will, but by mathematics. Each one reflects a small chapter in the same physical story. Stress, release, drift. It's comforting in a way. The more we understand how easily our minds draw meaning, the more careful we become about claiming it. To recognize a bias is to see more clearly. To step back from wonder doesn't kill it, it refines it. The mystery of Atlas remains vast, but it's grounded now in measurable truth. Our fascination with pattern is not a flaw. It's the reason we build telescopes, write equations, and look for stories in starlight. But science, at its best, doesn't extinguish wonder. It teaches us to aim it correctly, to marvel at the real instead of the imagined. As we watch 3I Atlas drift past Mars, followed by its gentle train of companions, it's tempting to trace invisible strings between them, to imagine choreography where there's only physics. But maybe that's the universe's trick, to let nature look like art just long enough for us to learn the difference. Our minds connect the dots. Physics tells us which lines are real. What makes 3I Atlas so different isn't just where it came from, it's what it's made of. Every comet carries the fingerprints of its birthplace, a record of temperature, pressure, and cosmic history frozen into its ice. But Atlas doesn't read like any textbook example. It's a collection of anomalies, contradictions held together by gravity and time. The first clue came from its spectrum, the light reflected and emitted by its glowing coma. In most comets, water dominates. H2O is the heart of their activity. As sunlight warms the surface, frozen water turns to vapor, carrying dust and gas into space. But Atlas defies that rule. Its emissions show carbon dioxide overwhelming water by a factor of several to one. The ratio is not just uncommon, it's almost absurd. A comet whose breath is carbon, not water. That alone would raise eyebrows. But the chemistry goes deeper. Within the tail, instruments recorded a signal for nickel that was unusually strong, while iron, the element usually paired with it, barely registered. In stellar terms, nickel and iron are twins, forged together in the death throes of massive stars. To find one without the other suggests something extraordinary happened to Atlas along the way. The working theory points to its long exile between the stars. Out there, beyond the protective bubble of our sun's magnetic field, cosmic rays roam unchecked. These high-energy particles slam into surfaces over millions of years, reshaping them molecule by molecule. They strip lighter atoms away, rearrange crystalline structures, and alter the balance between metals. Over eons, an ordinary comet could be chemically rewritten, its outer layers darkened, hardened, and turned alien. In that sense, Atlas is a survivor of deep time, carrying a surface sculpted not by the sun, but by interstellar radiation. When it entered our system, the sudden flood of warmth hit that ancient crust like a spark meeting dry tinder. The trapped gases beneath began to expand, searching for release. Unlike comets we know, whose surfaces vent evenly across wide areas, Atlas's activity came in bursts, localized jets erupting from discrete patches. Imagine a frozen landscape with fissures sealed for eons, suddenly forced open by heat. Each vent releases carbon dioxide with violent speed, propelling gas and dust outward in narrow plumes. These jets act like tiny rocket thrusters, producing random spins and jerks across the surface. This uneven propulsion creates torque, forcing the nucleus to wobble. Instead of spinning cleanly like a top, Atlas lurches, a motion scientists call non-principal axis rotation, or tumbling. As it does, sunlight hits new regions at odd angles, awakening fresh vents, which in turn add more chaotic motion. The entire object becomes a slow, unstable ballet of physics, a body trying to keep balance while its own breath pushes it apart. Each eruption sheds microscopic fragments, grains of dust, ice crystals, perhaps even centimeter-wide shards of crust. In the vacuum, they drift away slowly at first, then fan outward under the pressure of sunlight. To an observer, this appears as faint points trailing the comet, increasing over time, the very multiplying objects that have caught the world's attention. High-resolution imaging from orbiters near Mars confirmed this dynamic. The jets fire intermittently, creating bursts of material that move at slightly different velocities. Over days, they spread into visible clusters, faint but measurable. What looks like replication is, in truth, the choreography of disintegration. Each small flare of carbon dioxide becomes a sculptor's tool, shaping the surrounding dust into temporary formations of light. In close-up models, the process is mesmerizing. Microjets flicker like breathing, inhale, exhale, each one leaving behind a trace of glittering ice. The tail becomes less a static streak and more a living system, constantly rebuilding itself from what it loses. In this light, the mystery softens into elegance. The multiplication we see isn't defiance of nature, it's nature in motion. Some astronomers describe Atlas as a kind of chemical time capsule, others as a cosmic laboratory. Its unorthodox composition provides a glimpse of environments where water wasn't the dominant solvent, where carbon dioxide and nickel ruled instead. Perhaps Atlas was born in a colder, more metal-rich nebula, or near a young star that burned its volatiles away early. Every observation adds another line to a story written across billions of miles. When the data is plotted, the ratios of CO2 to H2O, the spectral balance between nickel and iron, the curves don't fit any known template. And yet, the physics holds. The heat, the gas pressure, the spin, the fragmentation, all align within the boundaries of natural law. That's the paradox at the heart of science. The most surprising things are often the most consistent. Each fragment drifting behind Atlas isn't just debris, it's evidence. Proof that the comet's body, ancient and brittle, is simply responding to the same forces that shape every other object touched by sunlight and motion. The only difference is scale and patience. The universe has both. In the end, the strangeness of Atlas doesn't make it alien. It makes it authentic. It reminds us that nature's creativity outpaces our expectations, that even within the rules we understand, there's infinite room for surprise. The multiplying companions are not errors. They're echoes of chemistry and time. When chemistry refuses our textbooks, nature writes a new chapter. Every great mystery carries two voices, the voice of imagination and the voice of evidence. When 3I Atlas appeared with its impossible chemistry and multiplying fragments, those voices began to argue. One whispered design, the other whispered physics. Both demanded to be heard. The engineered theory found early traction online. The timing was too neat, some said, an interstellar visitor arriving just as our instruments became sharp enough to notice such things. The fragments trailing behind it looked too regular, too synchronized, and the orbit itself, hyperbolic, precise, slicing through the solar plane at a clean angle, seemed almost purposeful, like a trajectory chosen rather than inherited. If this were an engineered probe, the reasoning continued. Then perhaps those fragments were not debris, but scouts, small autonomous sensors following a parent craft. Perhaps the variations in brightness were signals, or the shifting tail a kind of coded exhaust, and the coincidence of its path near Mars. An ideal vantage point, some mused, for studying a planet with both atmosphere and industry. It was an intoxicating thought. Humanity has always looked for intention behind the unknown. But science, steady and unromantic, begins with the checklist. Criterion 1. Orbit. Does it obey natural mechanics? Yes. Every acceleration, every curve in Atlas's path fits perfectly within Newtonian dynamics and solar gravitational models. no artificial thrust, no unexpected course corrections. Criterion 2. Emission. Any radio signals? None. Every frequency band from VHF to microwave has been scanned repeatedly by ground and orbital instruments. Silence. No pulse, no modulation, no carrier tone hiding beneath the noise. Criterion 3. Rotation and motion. Controlled spin? No. The nucleus tumbles irregularly, its brightness fluctuating in ways consistent with random gas jet activity, not programmed maneuvering. Criterion 4. Composition. Artificial alloys? Again, no. Spectroscopy shows volatile ices and native elements. Carbon dioxide, dust, nickel, no trace of synthetic materials, isotopic oddities, or metallic composites that suggest manufacture. One by one, the boxes on the engineered list remain unchecked. This is not the first time curiosity has walked this road. In 2017, Oumuamua entered the solar system on a similar hyperbolic path. Our first confirmed interstellar visitor. Its strange cigar-like shape and unexplained acceleration sparked the same question. Natural rock or alien probe? For months, headlines leaned toward wonder. Then physics caught up. The acceleration turned out to fit the behavior of a body shedding volatile gas, even without a visible tail. No radio signals, no artificial symmetry, just the quiet stubbornness of nature doing something unexpected. 2 years later came 2E Borisov, a more traditional comet, streaming dust and gas like a textbook illustration. It reminded the world that not every visitor from beyond carries a message. Sometimes they simply pass through. Atlas sits somewhere between these two. Its chemistry is stranger than Borisov's, but its behavior is grounded in the same physics. The multiplying companions, the erratic outgassing, the spectral anomalies, they all point to a fragile object stressed by the warmth of our sun. If it seems to act with intention, that's because natural systems often do. They follow patterns of energy and motion that mimic design, yet emerge spontaneously from their own conditions. Still, it's fair to ask, if it were artificial, wouldn't we see some sign? The answer is yes, and we don't. No geometry is too perfect, no periodic modulations, no structured heat signatures. The companions scatter at random velocities, their relative spacing inconsistent with formation under guidance. Nature may create beauty, but it rarely repeats it exactly. Artificial systems, on the other hand, leave fingerprints of repetition. Atlas leaves none. Even the timing, the coincidence of arriving during an era of heightened human attention, fits a broader statistical truth. We are watching more carefully now. Our instruments are more sensitive than ever. It's not that visitors are choosing this moment to arrive. It's that we finally have the tools to notice them. The universe has always been this busy. We just weren't looking. The debate continues, of course. Some find comfort in the possibility that we're not alone. Others find comfort in the completeness of natural law. But the beauty of science is that both impulses, imagination and evidence, can coexist without cancelling each other. One asks the question, the other refines the answer. In the final assessment, 3I Atlas behaves exactly as a fragment of interstellar debris should. Its quirks, hyperbolic orbit, odd chemistry, multiplying fragments, are not signatures of design, but signatures of exposure. They're what happens when an ancient traveler, scarred by radiation and time, meets the energy of a new star. It's worth remembering that mystery doesn't require intent. The universe has been performing wonders long before intelligence ever tried to explain them. To find awe in the natural is no less spiritual than to dream of alien architects. It simply honors the elegance of what already exists. So for now, the record stands. No beacon, no craft, no coded light, just dust, ice, motion, and a few dozen tiny fragments gliding in the wake of a comet older than our world. Extraordinary claims deserve extraordinary evidence, and tonight, evidence points to nature. Before 3I Atlas crossed our skies, it belonged to another story, a much older one, written in the architecture of our galaxy itself. To understand this traveler is to look backward, beyond the sun, beyond our solar neighborhood, into the great spiral body of the Milky Way and its layered history. The Milky Way is not one disk, but several. The thin disk, the one our sun lives in, is young and bright, filled with fresh stars and clouds of gas still birthing new systems. But beneath it lies another structure, older and thicker, like the fossilized bones beneath new growth. Astronomers call it the thick disk, a population of ancient stars, dimmer, redder, enriched by the heavy elements forged in the galaxy's earliest epochs. It is a place of long memory, where motion is slower, orbits are tilted, and time has softened the chaos of formation into something solemn. The chemical fingerprints of 3I Atlas match that age. Its ratios of nickel to iron, its abundance of carbon dioxide over water, these are not the traits of a young comet recently sculpted by a star. They're the marks of something that formed in an environment rich in metals and poor in volatiles, a signature consistent with the thick disk's earliest generations. Picture it. Billions of years ago, long before the sun existed, a star in that ancient region carried its own retinue of planets and icy debris. Somewhere within that distant system, collisions and accretions birthed a small body, perhaps no larger than a mountain, composed of dust, ice, and metallic grains condensed from the ashes of long-dead stars. It orbited its parent star quietly for eons, frozen and undisturbed. Then something shifted. A gravitational nudge, a passing star, a planetary migration. Some gentle but inevitable catastrophe disrupted the balance. 3 Atlas was flung outward, exiled from its home. Over millions of years, its orbit stretched and broke until the star's pull could no longer hold it. From then on, it drifted freely between suns, unbound and alone. Interstellar space is not empty. It is filled with dust, radiation, and invisible fields that leave their marks on anything that wanders long enough. As Atlas traveled through this cosmic wilderness, its surface endured a slow, relentless transformation. High-energy particles from exploding stars bombarded it continuously, breaking molecular bonds, fusing others. The smooth grains of its crust became pitted and darkened. Volatile compounds migrated inward, leaving behind brittle shells. Each impact of microdust, each pulse of radiation etched a new scar. Over time, these scars built up into a kind of armor, a hardened crust of altered chemistry. Where ordinary comets carry soft, porous ice that vaporizes easily, Atlas grew dense and metallic. The nickel-enriched skin we now see is not an accident, but the product of billions of years of exposure. The faint green-blue glow that follows it isn't merely reflection. It's the color of age, of cosmic weathering polished by time. By the time it entered our solar system, Atlas was not a newborn wanderer, but a veteran. Its structure had become fragile, its gases locked beneath layers that barely held together. When sunlight finally touched it again after perhaps a billion years of darkness, the response was violent. Heat cracked the crust, gas escaped through new fissures, and dust streamed outward. Each eruption released fragments that mirrored its history, ancient, irregular, and beautiful. Those fragments, the so-called multiplying companions, are not anomalies. They are memories. They tell us that even in space, nothing truly stands still. Every grain of dust, every shard of ice is part of a grand recycling, drifting from one star's gravity to another's. carrying the chemistry of creation like pollen across a galactic garden. To look at Atlas through a telescope now is to peer into prehistory. Its light has traveled not just distance, but time. Every photon bouncing off its surface comes from material older than our Sun, older than our Earth, perhaps older than the Milky Way's spiral arms in their current form. This is what scientists mean when they call it a messenger, not because it was sent, but because it arrived. When you see the thin trail of turquoise dust against the darkness, imagine it as a page from a diary that began before life existed here. Each particle within that glow holds atoms forged in long-vanished supernova, blended and reshaped across eons of drift. Even the way it breaks apart, graceful, inevitable, is an echo of how galaxies themselves evolve. Expansion, collision, renewal. 3 Atlas is strange, not because it disobeys physics, but because it carries too much history to fit neatly into our categories. The patterns in its fragments, the anomalies in its chemistry, the gentle curve of its hyperbolic path, all are signatures of endurance. 1 billion years of wandering have written complexity into every molecule, and what we see now as it sweeps past Mars is the culmination of that journey, a traveler shaped by everything it has survived. Ancient travelers carry ancient reasons. In the cold, thin air above Mars, machines keep their patient vigil. Orbiters circle the red planet in silence, their lenses pointed outward, not down. For once, Mars is not the subject of the gaze, but the witness. Beyond its faint horizon, a blue-green filament cuts through the void. 3I Atlas, nearing the planet's orbit like a passing ghost of another galaxy. The Mars Reconnaissance Orbiter, a veteran of 15 years in flight, captures the scene. Against the dark, the comet's nucleus gleams faintly, no larger than a pixel even in the highest resolution. Yet around that pixel, something stirs, a shimmer, a faint reflection barely above noise. Analysts at Mission Control enhance the contrast, stack multiple exposures, filter out cosmic rays. Slowly, the picture emerges. Trailing behind Atlas, a series of soft streaks appear. They aren't parallel. They don't line up neatly as a train of satellites might. Instead, they drift in gentle irregularity, like dust caught in a breeze. Some glow brighter for a moment, then fade. Others wink into view only to vanish in the next frame. It's not geometry, it's weather. To the untrained eye, the formation seems loose, even sloppy. But to the scientists reading brightness profiles and angular motion, it's precisely what they expected. The vectors don't share a common axis, meaning they aren't controlled or tethered. They diverge slightly from the comet's trajectory, each fragment following its own faint curve. The camera's instruments measure reflectivity. The faint echoes brighten during Atlas's periodic outbursts, when jets of carbon dioxide tear through the crust and scatter sunlight across fresh dust. Then they dim again as the gas disperses, and the fragments drift farther apart. When plotted across several days, the graph rises and falls in rhythm with those bursts, a breathing pattern etched in light. In the sequence playback, the comet and its followers seem to inhale and exhale, a flare, then quiet, another flare, then quiet again. Between them, the darkness hums, endless and watchful. From this vantage point, Mars plays a role no laboratory could imitate. Its red disk acts as a natural lamp, a diffuse backdrop that reveals motion invisible from Earth. The contrast between the planet's glow and the comet's turquoise tail makes each companion glint stand out, like beads of dew against dawn. It is a kind of cosmic theater. The orbiters circle above, their instruments steady, while Atlas drifts across the stage, scattering fragments as if rehearsing impermanence. In each image, Mars hangs beneath like an audience of one. Silent, still, unblinking. Scientists describe the view clinically. Fragment alignment loose. Light curve consistent with natural outgassing. Probable clustering due to localized ejection. But beyond the numbers, there's an undeniable sense of poetry. These fragments, far from mechanical precision, display a grace born of randomness. No perfect symmetry, no rigid spacing, just motion balanced between chaos and order. One researcher likens it to a string of pearls being unthreaded in slow motion. Each bead drifts outward, separated not by command but by consequence. The beauty lies in its imperfection. If this were artificial, the formation would be rigid, the pattern would repeat. Instead, every frame captures difference, slight, organic, unpredictable. As the comet continues its passage, Mars's orbiters follow, documenting the play of light. The fragments brighten one last time as solar wind catches the newly freed dust. For a few hours, they sparkle in synchrony, like the afterglow of thought fading into sleep. Then, gradually, the shimmer thins. What remains is the main body of Atlas, still glowing softly, still carrying the memory of its own unraveling. The data confirms what the chemistry already suggested. The multiplying objects are not signals, not artifacts of observation, but the natural byproduct of stress and sunlight. Each fragment's existence is temporary, a brief flare in the long sigh of the comet's evolution. They will disperse in weeks, leaving only faint traces detectable by the most sensitive instruments. And yet, the vision stays with you. The idea that another world, Mars, served as witness, providing the perfect angle for us to understand. That in the quiet theater of interplanetary space, two wanderers shared a single frame. The planet, barren and red, reflecting the sun's muted glow. The comet, fragile and blue, trailing a pulse of dust like breath made visible. If you were standing on Mars's surface that night, looking up from one of its frozen valleys, you would have seen a faint streak stretching across the sky, broken slightly into a chain. You wouldn't think of mathematics or vectors. You'd think of motion, of fragility, of time passing through matter. And in that stillness, perhaps you'd realize the mystery isn't about what the fragments mean, but about the quiet way they fade. From Mars's quiet balcony, the companions look less like a message and more like breath. Now that the comet has passed Mars and its trail begins to fade, the time comes to separate what we imagined from what we've learned. The data are in, the images catalogued, the numbers checked and rechecked. The question that began as a mystery, why the companions of 3i Atlas seem to multiply, has come to rest in a quieter place. Not in revelation, but in understanding. In research labs and observatories, analysts assemble their final comparisons. A table fills the screen. One column marked hypotheses, the other evidence. Engineered craft, unchecked. No radio emissions, no geometric spacing, no anomalous acceleration. Optical illusion, partially checked. Some early artifacts traced to imaging corrections, but real fragments confirmed by independent observatories. Natural fragmentation, checked. Dust, ice, and gas venting irregularly under heat, consistent across spectra and motion vectors. Temporary aggregation, checked. Clustering of reflective grains observed, dissolving with time. Unexplained phenomenon, unchecked for now, but never crossed out. Science leaves a margin for surprise. The beauty of this comparison is its simplicity. There's no need for hidden forces or coded messages. The multiplication of fragments fits neatly inside known physics. Outgassing, tumbling rotation, the push of sunlight, the fragility of an interstellar crust, meeting warmth for the first time in eons. Every thread we've followed leads to the same pattern of cause and effect. The real shift, perhaps, isn't in the sky, but in how we see it. With instruments like the Rubin Observatory and Mars orbiters, our eyes have grown sharper than ever. What once looked like solitude now looks crowded. We confuse resolution with revelation, detail with drama. But the universe hasn't suddenly become more active. It's our gaze that's expanded. Seeing more doesn't mean there's more to see. It means we've earned the clarity to notice what was always there. That's the paradox of progress. The better we perceive, the more we must guard against the illusions of pattern. Every new frame tempts us to connect the dots too quickly, to mistake curiosity for proof. The lesson of Atlas is that wonder and restraint must coexist. Media headlines rarely share that restraint. The story of a multiplying comet was too good to ignore. An easy headline, a hint of extraterrestrial design, a promise of cosmic intrigue. But real science moves slower than headlines. It breathes through peer review and calibration. The truth often sounds less cinematic, but it lasts longer. When the data settled, the simplest explanation stood untouched. 3. Atlas behaved exactly as a fragile ancient object should. What we called mystery was motion. What we saw as replication was release. Its fragments weren't multiplying, they were letting go. This realization doesn't shrink the wonder, it deepens it. Because the elegance of the cosmos lies not in its secrets, but in its consistency. The same forces that pull the tides, sculpt the clouds, and light our dawns also guide a comet born in another galaxy. Between coincidence and design lies a quiet truth: consistency. Perhaps that's the universe's gentlest message, that chaos and order are never truly separate. What feels like chance may simply be harmony too vast to hear in one lifetime. And so, the story closes without closing. Atlas drifts outward again, its companions fading, their light scattering into the dark. Another mystery will come. Another shape will challenge our understanding. But for now, the sky is calm, and our questions rest on steadier ground. What remains is not fear or speculation, but peace. The quiet satisfaction of having seen something extraordinary and finding it still obeys the rules. There's a moment after all the data and debate when silence feels like the truest answer. The comet fades, its fragments disperse, the screens go dark. What remains is not uncertainty, but a sense of proportion, a widening awareness that mystery is not a problem to solve, but a place to stand. We often think peace comes from knowing everything. But the universe, vast and unhurried, offers another lesson. Peace comes from living with what we can't yet know. The sky above us is always changing, and that change is the only constant we can trust. Stars are born, burn, and die. Orbits shift. Worlds collide and reform. What feels like chaos from one vantage is harmony from another. Somewhere out there, 3i Atlas continues its journey, already smaller, fainter, slipping beyond the reach of our telescopes. Yet its passing leaves something behind, a reminder of how fragile and magnificent perception can be. We saw it because we were ready to see it. That alignment alone of technology, curiosity, and time is its own kind of miracle. When you lie under the night sky, you share that same act of observation. Every breath you take contains atoms once part of a star. Every heartbeat sinks, however faintly, to the pulse of a galaxy spinning through dark matter. The distance between you and the stars is unfathomable, yet the physics that shape them also shape you. Maybe that's why the universe never feels foreign, even when it overwhelms us. We're made of its language, of hydrogen and carbon, of stardust and gravity. When you look up, you aren't gazing into something separate, you're looking into context. The thick disk, the solar system, the comet's luminous arc, They all move within a rhythm older than memory. It's a rhythm that doesn't ask for faith, only attention. To be aware of it is to be humbled, and strangely, to feel at home. You don't need to hold every answer to rest easy beneath this sky. It's enough to know that order and change coexist, that curiosity and calm can share the same space. We observe not to control, but to belong. As the night deepens, picture again that string of faint lights trailing Atlas, the fragments drifting apart, glowing softly before they vanish. They're still there, somewhere, even as their brightness fades beyond our reach. Like thoughts settling before sleep, they disperse, but don't disappear. Breathe with that rhythm. Inhale the unknown. Exhale the need to define it. Let the scale of it all make you lighter, not smaller. The same gravity that binds galaxies also holds you gently to this world. Curiosity keeps us awake. Serenity lets us rest. The journey ends the way most cosmic stories do, not with a sound, but with a fading light. Out beyond the orbit of Mars, 3I Atlas drifts onward, its turquoise tail dissolving into the vastness like ink thinning in water. Each passing hour dims it further. What was once a bright visitor in our telescopes becomes a whisper, then a trace, then a memory folded back into the quiet fabric of space. The companions that once surrounded it, those tiny glittering specks that seem to multiply endlessly, are fading too. One by one, their reflected light falls below detection thresholds, swallowed by the background stars. What remains are only the fixed points, the steady anchors of the night sky, the constellations that have always been there. In their calm persistence, there's comfort. The universe moves, but it never leaves us behind. Mars, now weeks past its brief alignment, has resumed its own slow circuit under the sun. The orbiters have turned their cameras away, back toward their usual surveys of dust storms and polar ice. Yet somewhere in their memory banks lies a sequence of frames, tiny dots of light drifting together across blackness. Data, yes, but also poetry in the shape of motion. From Earth, if you were to look up tonight, you wouldn't see Atlas. It's already too faint for human eyes, even through most telescopes. But you'd know it's out there, carrying the residue of our attention. The millions of photons we aimed at it, the questions we asked, the wonder we couldn't contain. That too is part of its journey. Every observation becomes a kind of companionship. There's something tender about letting it go. For months, it filled our screens and imaginations. It gave us a story of fragmentation and renewal, of chaos that still obeyed quiet laws. And now, as it fades, it leaves behind not loss, but perspective. What began as mystery concludes as gratitude. Somewhere in the far reaches of space, sunlight still touches the last particles of its tail. Those specks scatter in slow arcs, each one carrying a history billions of years long. They will keep moving until light itself can no longer follow, until even memory feels like an echo. Yet for us, the story is complete. We watched a traveler cross our sky, and for a brief span of human time, it let us feel connected to the infinite. If you listen closely now, to the hum of your room, to the faint vibration in your breath, you might sense a rhythm that matches the cosmos outside. The universe doesn't sleep, but it rests gently in its own cycles. Stars flicker, comets fade, planets turn. Every motion is another heartbeat in a system too large to fear, too vast to fully understand. Let that thought settle in you. The unknown is not a void, it's a cradle. The same dark that swallows the comet also holds us safely, spinning in our quiet orbit around a modest star. We are small, yes, but never insignificant. We are part of the same physics that guides Atlas on its way. So tonight, as you close your eyes, Picture that faint glow receding into the black. See the tail dissolve until it becomes indistinguishable from starlight. Feel the stillness that follows. It's not the end of a story, it's the beginning of rest. Tomorrow, the sky will turn again. New signals will appear, new questions will rise. Somewhere, another comet will wake from its slumber, and we'll begin watching once more. But for now, it's enough to know that everything is still in motion. And that motion includes us, quietly revolving, quietly breathing, quietly aware. Let the night hold you the way space holds its travelers, without judgment, without noise, with infinite patience. Good night, traveler. Carry our questions gently into the dark.